Okay, last video from Module 6. First topic is roots of a product of polynomials. So go back to when we found roots of quadratics by factoring. All we're going to do here is add one more step to it, and it's not too bad. So if we have, for example, u squared plus 11u plus 28 times 5u minus 10 equals 0. Okay, so same thing, we just set our factors equal to 0. The only thing that's going to change is that first, oops, and I put 25 instead of 28. Okay, that first polynomial is a quadratic that can still be factored more. Okay, so if you think about two numbers that multiply to be 28 and add to be 11, so if we do 7 and 4, and we're just going to have 3 solutions instead of 2. So if u plus 7 is 0, u is negative 7. If u plus 4 is 0, u is negative 4. If 5u minus 10 is 0, then 5u would equal 10, and u would equal 2. So we got the 3 solutions there. And that's it. That's all you got to do. Okay, so we can do another one. I'll find a good one here. Okay, so if we have u squared plus 4u minus 5 times 4u minus 36 equals 0. Okay, multiply to be negative 5, add to be 4. So we would have positive 5 and negative 1. So we'll have u plus 5, u minus 1, 4u minus 36 equals 0. So from this one, u would be negative 5. From this one, u would be 1. From this one, 4u minus 36 is 0, when 4u is 36, so u would be 9. Okay? All right, moving on. We have solving an equation using the odd root property, problem type 2. Okay, this one's, I think, one of the trickier ones in this module. We've put together a couple things that we've already done. So we did this with squares. Now we're just going to do it with cubes. Okay, so something like this. So again, you get the 80 to the other side. Okay, then you would cube root it. Oops, negative 80. Okay, and then we would add the 4. Now, the only thing is that you have to try to simplify that cube if you can. Okay, otherwise that would be your final answer. But remember, if we want to simplify the cube root of negative 80, we need to figure out a perfect cube that goes into the 80. Okay, and they do want you to take it out if it's negative, because remember, you can cube root negatives, you can't cube root positives. So we don't want to leave a negative under the radical. Okay, so again, your perfect cubes. 2 cubed is 8, 3 cubed is 27, 4 cubed is 48, 5 cubed is 125. They're probably not going to go beyond that. Okay, so we can split this up into the cube root of negative 8, cube root of 10. And like I said, we can cube root negatives. Okay, so the cube root of negative 8 is negative 2. Okay, think about that for a second. If we do negative 2 times negative 2 times negative 2, you have an odd number of negatives. So it's still going to be negative, and it's going to be 8. Okay, so we're going to have 4 minus 2 cube root of 10. Okay, or you could write negative 2 cube root of 10 plus 4. Doesn't matter. Okay, so either of those answers work. Let's do another one. Okay, the next one, x plus 2 cubed plus 48 equals 0. So x plus 2 cubed is negative 48. So x plus 2 is the cube root of negative 48. And then we can subtract the 2. Okay, now your cube root of negative 48. Okay, oh, you know what I did up here? That was stupid of me. I think I must have been thinking ahead. 4 cubed is 64. So I messed that up. Okay. But we can split this into the cube root of negative 16. No, 8. 16 is not a perfect cube. 8 is again. Right? And like I said, they're not going to throw anything too big at you there. It's usually going to be 8. And then the cube root of 6. So we have negative 2 cube root of 6. Okay, so we'd have negative 2 cube root of 6, and then minus 2. Okay, all right, next one. This one is not too tough. It's one of those long ones. So we have solving a rational equation that simplifies to quadratic with a factorable quadratic denominator. Okay, so go through the steps for one of these. You've got negative 10. We've done these when they simplified to be linear. Okay, so it looks really messy, but what's usually going to happen here is that quadratic denominator can be factored, and the other two denominators are its factor. Okay, so what you're usually going to see in a problem like this is that w squared minus 4w minus 21 is w minus 7 times w plus 3. Okay, and it is. So we would have negative 10w over w minus 7 times w plus 3 minus 8 over w minus 7 equals w over w plus 3. So if you remember, we can clear our fractions by multiplying everything by w squared minus 4w minus 21. Okay, or that w minus 7, w plus 3. Okay, so when we distribute that to every term, the denominators will all cancel out. So when I distribute it to the first term, the w minus 7 and the w plus 3 cancel out the w minus 7 and the w plus 3, so I just have negative 10w. When I get to the second term here, the w minus 7s will cancel out, so I'll have negative 8 times w plus 3 equals, this last term, the w plus 3s will cancel out. Okay, now I can expand everything. Be careful with distributing that negative. Right, negative 8w, negative 8 times 3. Okay, so I guess I'm going to write here, we cleared fractions, and then we expanded. And now we want to set it equal to 0. So we want to get everything to one side. And we want the squared term to be positive. So we'll get it all to the right-hand side. Okay, so 0 will equal w squared. We're going to add 18w. Okay, so that's going to be plus 11w plus 24. Okay, now we can factor. Multiply to be 24, add to be 11, that's going to be 8 and 3. And now we can solve. W equals negative 8, or W equals negative 3. Okay, you do need to check your answers in here. If you look up here, W can't equal negative 3, right? W can't equal 7 or negative 3 because of those denominators. So that negative 3 isn't going to work, and we only have one answer. Okay, we'll do another one of those. Those are very tedious. They take a long time, but they all have the same steps. Okay, so we'll follow those exact same steps again. So for our next one, we have 3 over u minus 5 plus u over u minus 4 equals negative 4 over u squared minus 9u plus 20. Okay, and just like I said before, u minus 5 times u minus 4 is u squared minus 9u plus 20. Okay, so we're going to multiply everything by u minus 5, u minus 4. Okay, so again, when you distribute to the first term, the u minus 5s cancel out. Distribute to the second term, the u minus 4s cancel out. Distribute it to that third term, and everything cancels out. You just have the negative 4. Okay. Before we get too far ahead, remember u cannot equal 5 or 4. So if you get that as an answer, it's not going to be correct, okay, because of those denominators. All right, expand. Get everything to the side that has the squared term on it. So we'll have u squared plus 3u minus 5u, so minus 2u, and then minus 16. Oops. Plus 4, so minus 8. Okay, and then we can factor that. U minus 4, u plus 2. So u equals 4, or u equals negative 2. But remember, 4 is one of our excluded values, so just u equals negative 2. Okay, we are very close to being done here. Next one, we have solving a radical equation that simplifies to a linear equation. They're calling this one radical advanced. Okay, so a problem like this. We have something like 2 equals the square root of 5x minus 21 minus 1. Okay, so we've got a radical in there. We want to get the radical by itself. We're going to isolate the radical so that we can square both sides. Okay, so we're going to get that 1 out of there. So we'll have 3 is the square root of 5x minus 21. Okay, and then if we square both sides, we'll have 9 equals 5x minus 21. Okay, and then it's just a simple linear equation to solve. So 30 would equal 5x, so x would equal 6. Okay, what makes this advance is you got to check your answer. Some of these your answer won't work. So 2 would be the square root of 30 minus 21 minus 1. So the square root of 9 minus 1. So 3 minus 1, and that works in this case. All right, we'll do another one. I'm just trying to see here. Oh. Okay. Oops. All right, we have the square root of 2w minus 3 plus 1 equals 4. Okay, so again, you isolate the radical, so we're going to subtract 1 from both sides. Okay, square both sides, and then solve. So we would get w equals 6, and then we're going to check it. Okay, so we've got the square root of 9 plus 1 equals 4, 3 plus 1 equals 4, and it works. Okay, so w equals 6. Then we can move on to your last topic, which is solving a radical equation that simplifies to a linear equation with 2 radicals. This one's also very straightforward. You just got to check your answer. Okay, so we'd have something like square root of 7y minus 14 equals square root of 3y plus 14. Okay, so if you just square both sides, you get rid of your radicals. So 7y minus 14 has to equal 3y plus 14. Okay, so if we add 14 to both sides, we'll have 7y equals 3y plus 28. Subtract 3y from both sides, so 4y is 28. Make y 7. Check your answer. 7 times 7 minus 14 square root equals 3 times 7 plus 14 square root. So we'll have 49 minus 14 square root, and then we'll have 21 plus 14 square root. Square root of 35, you don't need to know because the other side is also square root of 35. So check, good, works. Okay, I'm going to pick one more example to do, and then we're done. Okay, so we've got the square root of 8w minus 15 equals square root of 6w minus 3. So square both sides, 8w minus 15 equals 6w minus 3. Subtract 6w from both sides and add 15. So w would be 6. Check your answer. And let's see, we'd have 48 minus 15 square root, so square root of 33. And that'd be 36 minus 3. So it works. All right, that's it.